I would like to turn now to a very important subject that I don't have time to handle at all in detail, but at least I can give you the glimpse of it, okay? And these are two topics. Number one, parameter variation. Number two, calibration. Okay. Both of them share a certain characteristic, okay? What are these characteristics? The characteristic they share is that they represent a radical departure for what we've already been doing, which is running the model once for each run. So far, when we run the model from an experiment, it brings main into existence once, runs it, and then it finishes, and that's the end of the experiment, and it's the end of main, right? With parameter variation experiment and calibration experiment both, we have a very different situation. We instead have a situation where we are going to run this given model many, many times over. Okay, the model will be run not just once, but many times for different purposes. For parameter variation, sometimes it's done just to account for stochastics. So we want to develop some sense that the results are robust and not just due to a fluke of chance. We want to run the model many times, make sure the results stay stay solid even for across those realizations. We want to see a degree of variability. Secondly, for parameter variation, sometimes we want to change parameter values, parameter assumptions, and see how it changes things. By contrast, for calibration, we're trying to adjust assumptions about parameters so that the model results best match observed data. Okay? So I'd just like to give you a glimpse of these. So what I'm going to do is I'm going to add in to this model an experiment. I'm going to save this now as version 4, and I will output this current version up to the site in case anyone wants to grab it there. Okay, here we go, and file upload, and here we go, there we go, and model v3 ALP, and I'm wondering if I should also put up the Excel file, but maybe does anyone want the Excel file too? No? Okay. I'll just update this. Boom. There we go. Okay? Boom. Notice you needed to have that Excel file have the two sheets already in it. Okay? Maybe I should update it just in case. Here we go. Boom. Ready? Done. Okay, so it's uploading it. There we are. Okay, so let's go here. What we are going to do is we are going to put in place a bit of mechanism in the form of an experiment. I'm going to do new experiment, and I am going to do, there's several things you could do, but I'm going to do the ones that are well supported and exist even in PLE. Parameter variation experiment, okay? Parameter variation experiment should exist in PLE, okay? I output parameter variation. Now, ladies and gentlemen, time is a fleeting, opportunity costs loom large. But I'm going to do something quick. May I do something? Okay, thank you. Let's go to Palette. Let's go down to Analysis tab. And I would like to drag in something you've never seen in your models before. And that is a histogram 2D data set. And this is going to be called fractional prevalence. Histogram 2D data set. I was kind of expecting a comment from the peanut gallery there. And now we're going to
long since proved their inefficacy to exact any kind of change.
I believe the technical term is that you are incorrigible.
Okay. Well, it also serves as a not inconsiderable inducement to use autocomplete.
Indeed.
You get punished severely.
That's right. That's right. So if we go to this histogram 2D object, it will be called, in turn, fractional prevalence histogram 2D. Okay? Fractional prevalence histogram 2D. Now, ladies and gentlemen, I would like you to show bins with it. Show bins. And we're going to add a histogram data. What histogram data do you think we'll add?
Data set?
Indeed, it will be the data set. So this will be fractional prevalence. What's that?
He's just hiccuping like
Yeah.
crazy and funny.
Insane.
Okay. Gosh, I haven't noticed any previously.
Good.
And the histogram will be fractional prevalence histogram 2D data set. Are you okay with that? Are you okay? Okay. Ladies and gentlemen, so we have this histogram 2D. This is going to summarize over many runs of the model the results. So you're going to have one run on there from one run of it, and from another realization, from another, and they're going to accumulate in this 2D histogram. 2D in the sense that you have it in bins that are distinguished by time on the x-axis and by value on the y-axis. So for a given time, you're going to have a histogram over values that were achieved across different realizations. Some realizations had a high number of values of fractional prevalence at that time, some low. And it's going to be binned up across time and across the value. Okay? So a given time slice will give a histogram and value of fractional prevalence at that time, but we're going to have it for different sets of time. Okay, are we ready? Okay, now let's go to the 2D data set, and you'll notice that you can frob the number of intervals. We're going to set it to be 365 intervals. Oops, 365 intervals from 0 to 365, and the number of intervals in the y-axis range, this will be measuring fractional prevalence, will be 100 from 0 to 1. So where am I? I'm in the 2D data set. For the x, this would be 365 intervals from 0 to 365. For the y range, ladies and gentlemen, this will be 100 intervals from 0 to 1. Are we okay with that? Ladies and gentlemen, having done that, we are close to the cusp of greatness with respect to getting this running. Okay? You've done the worst of it. Worst of it, at least in terms of work. Now is something that might scare you a bit, but won't be too bad. Okay. Okay. So let's go to parameter variation. Make sure that's extended, and then I'd like to scroll down here, ladies and gentlemen, and I'd like to make sure the for randomness, you choose random seed. Do you see that? Random seed. It's under randomness. This is in the experiment, the parameter variation experiment. Do you see random seed? Ladies and gentlemen. Next, I'd like you to go down to Java Actions. Okay? Okay. Okay, now, for the initial experiment setup, I would like to type fractional prevalence 2D histogram data set dot, what do we always do before filling a histogram? We do a reset. Okay? So basically, the way this is going to work is it's going to run main many times. And each time it runs main, it's going to get some result. That result's going to live in main. We have to suck that data out of main's data set and put it into this 2D data set. And then main's going to disappear. It's going to be destroyed, and then we're going to run it again. And then we're going to run it to its completion. We're going to suck that data out, put it to this 2D data set, and then we're going to destroy main, and then it's going to run again. And it may run 100 times, it may run 1,000 times. Those are different realizations. This is called the Monte Carlo ensemble. Okay? And a similar thing is going to occur with calibration, by the way. But here, we're going to do it here. And then the other entry you have to fill in after simulation run, after main runs, after it does its job, ladies and gentlemen, this is what I'd like you to do. Are you ready? Okay. You're going to take the data from main that lives in a data set in main. What data set? Ladies and gentlemen, this data set, fractional prevalence data set that we created in main. Do you remember that one? And we're going to stick it in to the 2D data set here. Are you ready? This won't be too painful. Okay, so fractional prevalence histogram 2D data set dot add. And you notice when we do this, we say dot add, it gives us two choices. We could give it a whole data set. Whence does that data set come? It comes from where? Whence does that data set come? It actually comes from main. This is this data set here in main we want to get. And the way we say get it from main, I wish we could say main dot, but alas, we can't. We need to say something more primal in character. We need to say something you've seen once before, but only seen me remark on in glimpse. Root dot fractional prevalence data set. Main name here is named root. Because we may have a model where main is named something different. For example, reflecting its comparable size, it could be called Tasmania. Right? And so its root is the top level class, whatever it's called, main or Tasmania or whatever. Okay? We're all set. That's all we should have to do. Are we ready to run this thing? The other thing I should just go up and check. I'm going up to the top. It's saying, okay, for the parameters, if we scroll up to the top of this, ladies and gentlemen, you'll notice that in the parameter section, it'll say freeform or varied array. I'd like to change it to freeform, and I'd like the number of runs, ladies and gentlemen, to be 50. 50. This is in parameters of this parameter variation experiment. Are we ready for that?
Could you go back to the Java actions?
Sure. Yeah. Here we go. After initial experiment setup, this is what we have. I'll put it up on the big screen. That's in the experiment setup, initial experiment setup area. Just resetting the data set. Is that okay? Kurt?
Not like it. For
Okay.
some reason the complete isn't working. The word complete.
Okay. Yeah, that I do find that occasionally happens.
The autocomplete?
Yeah, I don't think, yeah, so
That sometimes happens, but it could be a warning that
it's not a thing.
that is not a thing. Yeah. So.
Yeah.
So what you do is you start by going to the very beginning,
Okay.
or just type a single letter, and then try autocomplete. Oh, it's working. Yeah, so autocomplete is working. So it looks like you can start typing as it goes too.
Yeah.
If you type like a
FR.
See, for some reason the data set,
Okay.
the data set isn't showing up.
you're in the.
You should be
That's because you're in the variation experiment, but the data set is in main.
that data set should be in the and the histogram associated with it should both be in the parameter variation
It
experiment.
should be in the experiment class.
Ooh.
So this is a bit like you create something within the person and you're in main trying to call it.
I I see. Okay.
Okay, ladies and gentlemen, so so can you cut those things and put them into the experiment? This is a very important point, folks. It used to be that an experiment was coterminal with the main. The experiment would run, when the experiment ended, main ended.
Consider dragging.
When main ended, experiment ended. That was it. Now, the experiment outlives main. So we have these constructs, the data set and this chart in main. I'm sorry, in the experiment, and it's running main many times. How many times is it running main? I'd like to especially be sure Ned caught this. It's in the parameters area of this experiment, and it's under, make sure it's free form, 50 times.
Got it.
Okay? 50 times. Are we ready to run it? So this is going to run it 50 times and summarize the results. So we're going to see how much variability there is. Now to run it, ladies and gentlemen, I'm going to do this. You're going to want to pay attention. Run, and then you're going to want to press this green button here. And what is it doing here? Can anyone see? Well, this is showing over different weeks the outcomes. Okay? This is over different weeks, it's showing outcomes here. Now, this is only going up to 100, and I think we're showing needlessly the sort of chart area, and I'm going to try to look to see if we can make that smaller. We need to move on, so I don't want to spend too long on this. Oh, the X value range, I said from 0 to 365. Okay, I'm going to make it from 0 to 100, just so it's more visible, because it looks like the infection. Oh, of course. Okay, sorry folks, let's keep that at 365. Ladies and gentlemen, what this is going to be, parameter variation experiment baseline. Okay, Kurt, do you want to see?
Yeah. Did you guys fix it, or?
I probably just spelled something wrong, so maybe it shouldn't come up.
It's funny, I think like 90% of all the errors has been that.
Okay,
Everybody.
ladies and gentlemen, I just renamed this experiment parameter variation experiment baseline, and now I'd like you to do copy and paste, and we're going to create a parameter variation experiment long. It's going to be month-long parameter variation experiment, parameter variation month-long
Dot what?
immunity
Add?
rather than 270 days.
Yeah, because it's treating it like a function.
So
and then
can
it's-
anyone tell me, how would I set it to be month-long immunity? Where would I go?
Yeah.
So Ned, I just copied the experiment,
Yep.
and I went up and pasted it here. And I renamed it parameter variation month-long immunity. Or you might call it PV month-long immunity. Okay? Where would I set it to be month-long immunity? Well, I'd go to this parameters area, and I'd set the parameter that says duration of immunity in days to 30 from 270. This one here. Set it to 30. Do you see that? Okay, now let's run it. Run that one. Run. How do I run it? Well, I press this button up here. And now it's starting to run it out. Now I'm still only seeing it out to 100 days. And that's a curious thing for me. It is out to 365 here, and I can go look at this data set. This is the actual 2D histogram. And
Is that up to 365?
sorry?
It's 365 by 100. Right.
Oh, I know what it is. Okay, sorry. I think I suspect I know what. There it is, ladies and gentlemen. Okay, Kurt, you'll want to watch that they get it.
Yeah.
Okay. We're going to want to have a stop time. We're going to want to have a stop time for the experiment of 365. And the same thing for that baseline, stop time of 365, okay? So just watch that. It imposed 100 arbitrarily. Make it 365, okay? So now we should be able to run, so the experiment should have a stop time of 365. So Ned, is yours working now?
Yep.
Okay, great. So the stop time for the experiment should be 365, and this is, it's trying to output the, oh man, okay.
That's a lot of entries.
Okay, ladies and gentlemen, that's the result right there. So you could see some variability. Why was it giving me trouble?
Because your file is open?
It was trying to output the file. Yeah, so let's have it run to time 364. Okay, stop time 364 for both of them.
Because you put that.
Because I told it to output it instead of on destroy, I told it to do it at 365.
Yeah.
That's one of the problems of that.
So that means for all of your parameter variations experiments, it was updating the value of that file.
Yeah, trying
Trying
to,
to.
yeah. Okay, ladies and gentlemen, here we go. So what is this telling us? Can you see something on your screens? Similar? So what this is telling us is that, across different runs, across different runs, we have some variation, not surprisingly. It tends to be high at first, and then the number infected tends to be high, and then it tends to stabilize and tends to fluctuate in this. But what is this one down here? What is this one, do you think, at the bottom? That's indicating for a small number of runs, there's actually probably zero people. In fact, it died out before catching, probably. Now, I'm going to run this more than 50 times. I'm going to run it 500 times and see what the results are, just so you can see it. You don't have to do the same. While this is running, you could down here notice there's 2 bars here. Anyone want to hazard a guess as to why there's 2 bars? 2 bars on. Well, in this case, it's running on 2 processors. I've told it can use 2 processors. Told Windows thing it can use 2 processors on my machine. So it's running across multiple processors at the same time. And here it's running it, and here we're getting the results summarized. So this is a 2D histogram. It gives a sense of variability in the results across those multiple runs. And what you can see is there is variability from realization to realization, but there's also broad regularities. It tends to be high first, and then you tend to have sort of an upsurge. This part tends to be significantly higher and then comes down. Maybe there's a bit of fluctuation, but it tends to lie in this range after a while. And that's in light of the fact that different networks are being formed from run to run, different vagaries of who starts infected and where it goes to. Still, you get a lot of regularity out of this. And you can't hang your hat too much on whether it's up here or down here, but it's very, very unlikely that you're going to see a count in here. But you have a non-trivial bimodal distribution here, where this is high and that's high, right? But then there's very little in between. Parameter variation experiment, okay? Now, let me just show you one other thing here, and we're going to need to move on. Now I want to say parameter variation, ladies and gentlemen, baseline, parameter variation varying immunity duration. I'm going to run different runs of this model varying the parameter, the immunity duration. Now we can do this in 2 ways. One way to vary it would be to actually draw it from a distribution. We could draw it from a normal distribution, max of 0 and normal centered around, maybe with standard deviation 50 centered around 270 days, something along these lines. We could do that. I'm instead going to show you a more structured way to do it, where we vary it in a range, and we vary it from, say, a minimum. So this one, we're going to choose range, and it's going to be varied from a minimum of 10 to a maximum of 300, or say a maximum of 500 with a step size of 10. So now it's systematically varying this parameter and running the model, and it's going to summarize its results in that chart. So the previous one, I was summarizing the results of running the model with the exact same assumptions again and again and again. Now I'm summarizing it as I vary those assumptions. How does it? How do the results vary? And you can see there's 50 runs it did for each of these gradations. In other words, when it was 10, when it was 20, when it was 30, just incrementing it by 10 each time, 30, 40, 50. And you can see that there's, most of the runs seem to have actually a peak down here. There are some that have it larger. I could start at a higher value, say start at a minimum of let's say, well, okay, yeah. If it's higher, then it will tend to be 0. So I could do 10 to, say, 100, something like that. Try running that, and now it will run it again. And there will be different runs. You can see some of them are up here, but most are actually down here, even by 100. Now, for each of those runs, I could further run with a given value for that parameter. I could further run a model with what are called replications, say 10 times. So here I am varying this parameter systematically in this range from 0 to 100, step 10, this duration of immunity in days. In order to do that, I created a new experiment and selected it to be varied in range. So Kurt, maybe you want to help Sean get...
Now I've got to search something for my son.
Okay, you bet.
And by the time we're not going to catch up in the amount of time we have left.
Okay, sure. So here, now I'm running it 10 times with these replications. For every value of that parameter, I'm running it 10 times over. 10 times, okay? Now, calibration, realistically, I don't have time to do much justice. What I will point you to is an example model in AnyLogic that's very helpful for understanding it. What you just saw, okay, so